Hi and welcome this evening to Caribbean Developer Week. And this evening we have Shannon Clarke. And our topic of discussion for this evening session is coding decentralized apps on Ethereum blockchain. So here's a bit about Shannon. He's a developer at Polymath.network and works with blockchain apps on a daily basis. And he has a few small tech startups and have experience in raising funds in the retail, tourism, and digital healthcare industry. Welcome, Shannon.
Hey everyone, how are you doing?
Okay,
So,
so I'm handing you over the floor.
okay, just a minute. Yeah, hi everyone. So, basically today, first thanks, Kadra, for the introduction, and thanks to both you and Lasana, and whoever else is working with you for organizing this. Very much needed. Especially thanks to the other presenters. So today, just going to make a simple app that will run on a local instance of the Ethereum blockchain. Not sure if anybody has heard about Ethereum, but most of you have. It's very similar to Bitcoin, except that it's really programmable, so you can write apps on it. You can do so with Bitcoin as well. However, unlike Bitcoin, Ethereum came with a Turing complete language, which means you can easily build apps on it, which is called Solidity. So essentially what we'll be doing today is that we'll be using the Truffle suite in order to build a simple smart contract, and we'll interact with that smart contract using JavaScript. Okay, so just to take a quick look back over, so I'm literally just going to look over a couple of the websites themselves, and then we just jump right into it. So if you're using Ethereum, there are a number of ways that you could get started. So for instance, you could actually connect it directly to the actual Ethereum network. This is the main Ethereum network. Or you could download what they offer, the developers of Ethereum, actual instance of the Ethereum wallet, and then start connecting to the blockchain. We're not going to do that. But what we'll do instead is that we'll use this useful tool called Truffle. So what Truffle essentially does is that Truffle makes it easier for you to not only write your smart contracts, but also build them and deploy them. So Truffle itself, actually, you know what? Maybe I should take a step back. The Ethereum and other cryptocurrencies like it actually run on something called a blockchain. And if I oversimplify it in the most simple ways possible, it's essentially a database that runs its individual instance on each person's computer, each connected computer. So it's a truly decentralized database, right? Now, what this means is that you can store information on this database, but you can't get to that information using the typical methods. But what you can do, however, is that you can write programs that connect directly to it. So that's why we have to use this thing called Solidity. If I just may go back here, and one of the interesting things about Solidity is that you can actually make something called a smart contract, which is essentially a state machine that says, if this, then that. And these smart contracts is what has powered a lot of the ICOs, the initial coin offerings that we've seen out there. I think talking is probably a little bit boring, so let's just get into a little bit of code. So here we are. This is Truffle, and Truffle, like I mentioned, is really used for writing our code. I'm building the smart contract itself. A couple of features from Truffle, because you could actually write smart contracts with Truffle, but essentially you're building your smart contracts. You can use testing, and then most importantly, deployment and migrations. Now, one of the interesting things that they have done is that they've provided this tool called Ganache. And with Ganache, we can quickly launch our own blockchain. So here's the first thing to anybody that's watching in right now. You can actually follow along by downloading Ganache. It should also be available for Windows as well as Linux. So I already have my own instance of Ganache running. Now, what's important to notice here is that these are the different Ethereum addresses. What are Ethereum addresses? I really shouldn't be going into all this, but essentially it's just like your email inbox. So how you have an email address. Well, now with this, you can actually receive data to your address. This is your blockchain address, basically. And the type of data that you get could be varied, but all of it must be compatible with the Ethereum network. And one type of data would really be a cryptocurrency called Ether. That's what you're seeing here. Now, just like how if your email inbox, you have a password, with cryptocurrencies and with blockchain, you have something very similar to a password, but it's called a mnemonic. And that's represented with this 12-word phrase. This is cryptographically generated, and the trillion-dollar question is, can this be hacked? Anyways, now since it's a blockchain, each transaction is actually represented in blocks. I actually started up this blockchain on my own. So if I did something like what you almost let you see, I just quit this, and then let's say that I start this up. Now you're actually going to notice here, how come I have 100 ETH on each? That's just how it initializes. But also when you check here, you see that down back to block 0. So the blockchain itself literally is a chain of blocks representing all the transactions that's happening on the network. And for each transaction that happens, you need to fuel the transactions. This is decentralized because one computer is not providing the processing power. So you basically have to pay for other computers to do the processing power. And hence we have our blockchain happening, and we can see that we've had no transactions so far, and the logs are just setting up the actual blockchain itself. One other thing to notice is that here I can configure my port number. I can see different accounts I've set up. Well, I can configure what the settings parameters are for transactions and so on. So just cancel that. So I'll also cancel this. So let's get started here now. So what I'm basically going to do is something called, I'm going to do an example of simple app. You could find it online. Basically to represent voting on the blockchain. Let me just hope that everyone is still seeing my screen. Yeah, and I already have MetaMask installed, which you'll see shortly. And if this basically, I'm actually grabbing this information from the blockchain, and then I'm going to vote for a candidate. Remember I mentioned about transactions happening just now? And this is how, using MetaMask, this extension, which we'll get into shortly, I can actually confirm a transaction. I'll then see this transaction starting or not. Oops, there's an error on this. This is interesting. Okay, probably a problem with that one. So the best way for us to debug it is to just build it right over. So let's do that. Okay, so I'm in. Let's see. Right. So I'll just get started here, make there. I'll say voting app. Then if we go back to Truffle, there's Truffle, right? You'll see that to get started. Sorry, my apologies. I am assuming that you have Node installed. Here's my version for Node as well as npm. So please make sure you have those. So for you, you would most likely have to run npm install Truffle. Then you can go to quick start. Truffle has something called boxes, which is basically pre-configured projects, but we won't do that. What we'll do instead is we'll just get started with, we'll initialize a quick project. Not seeing it there, but what we could do, we do just truffle init. Very similar to npm init, which would create the package JSON file to initialize a project. Just do truffle init. And if we do our lsnet, we see a basic structure right here. So for instance, if I just say, okay, I'm going to open up this folder. Then you can see that I already have basic config set up already. Now here's where I'm going to have to configure this to actually connect to my Ganache that's running. This is my local blockchain. I want to do that first. What I'll first have to do is that I'll have to write a smart contract in this contracts folder, and I set up my migrations here. So essentially what Truffle init has given me, it's given me this basic smart contract that would allow me to migrate contracts to Truffle, as well as a migration script. So you notice that it's already referencing that same migrations.sol. .sol is really the extension for Solidity files. Now that I have that, and because I need node, I'm going to run npm init, and then I could just hit enter on everything. Alternatively, I could have written npm init y, which would kind of just skip that whole step. Refresh, and you can see that I also have my package JSON right there. Okay, cool. Now, next step. Next step is actually to get into Solidity. Oh, I think we have, I wanted to find a quick tutorial on Solidity, a quick explanation of Solidity. So with Solidity, you're essentially writing to a blockchain. And I think the simplest way to consider it is really Solidity is, well, Solidity is similar to, Solidity is the blockchain, what SQL is the databases, right? However, it's also very similar to JavaScript. So if we're saying that, okay, we want to be able to write a voting app, then we need to start thinking, okay, well, what does a voting app actually entail? Well, with a voting app, we need to have candidates to vote for, and we need to have people that, well, can vote for it. So we need to keep track of has everyone only voted once? How many votes has each candidate received? Which is essentially what the app just now was supposed to show. Didn't though. Probably because there's some problem with Ganache. That was the error at least. So what I'm looking at here is Remix, which is an Ethereum IDE. This would allow you to write smart contracts. This is it here. And also deploy them through their IDE on a test network. However, we won't do that because that won't be fun. What we'll just focus on is just the use of Truffle in order to deploy to our local network. Okay, so we go back to the code itself now. Let's create a new file, and let's call it voting. Anybody who's actually voted before, which I hope everyone has, well, you would remember that you probably had to write down a piece of paper, and that's no fun. So let's get started. So to get started with a Solidity file, you're going to first declare it. Very similar to like writing maybe doc type, my HTML file. So we call it fragment Solidity. This is the version of Solidity, and then like I mentioned, it's you're gonna write a contract. is our smart contract. Now, this is essentially just declaring that, okay, we're going to have a table, basically, smart contract. So here now is how we're actually going to define our candidates. And let's just call this num votes. Now, what else do we need? We need to first define candidates. And we need to record votes. We need to map candidates to ID. Or just say find candidates. Then what we also need to do is we need to find a way. Okay, now we have this structure. How do we add candidates to that structure? So essentially what we do then is we create a function called add candidate. In Ethereum, by default, every function is called public. But if we don't want to expose a function, then we just call it private. And then in this case, then, so, well, we do need to keep track of how many candidates we have. Do we? No, we don't actually. So now what we're going to have is that we're going to have so we're going to create an array. Yeah, we do have to keep track actually. Candidates, number of candidates, and candidates count. This way then we can actually populate an array of candidates. This is referring out candidate, which is the same structure here, which means then we need to then implement, we need to give it these same functions here. So for ID, this is why we need candidates count. For ID, then we just, since it's a U integer, then we use candidates count. We could give it a name, like we could say Bob, and then we could say that Bob has 0 votes. Okay, so how do we test this? One way that we could test this is that we could go back to remix. This is this balance.sol, which is a template solidity file. This is just what they give us, but we don't have to use that. So we can call this floating. Now I do need to add the fragment. Sorry, I should ask. Is everybody still hear me?
Yeah.
Awesome. Cool. There we go. Fragment, and then we have candidates. Oops. I did not define candidates. Not sure why it's not letting me compile. Oh well, it should be candidates now. I've done this earlier, but trying to figure out why it's not working. Just give me a minute. Public, maybe function, expected. Oh, always read your error messages. Okay, I'll compile. It's gonna work. Parse error expected. Oh, expected semicolon. Now let's figure out which one I should use in this case. Nope, cancel. Let's see. This. So actually, interesting enough. Actually, yeah. Why not? Why not take a look at this right now? Like this is actually referencing my accounts right now. I'm not able to compile this on remits. This is interesting. So what I'll do instead, while I try to figure out why that isn't working, or why that wouldn't do what I want, is that I could actually, so going back to my Alternate app, I can actually run Truffle compile. But the reason why this is not working is because I have an error expected. Oh, right, because it's the same problem. I'll say it wrong. Oh, I should probably copy over the code I just did here. Let's see. Yep. Does it behave yet? It doesn't. Interesting. One of the things I actually forgot to do though, when I think about it, is I actually have to set up for my network customization. So this is inside the Truffle documentation. But basically what I'm doing here is that I'm defining, okay, so we're running a local node of the Ethereum blockchain, and it's going to run on 7545, and it'll just match any network ID. Actually, no, I'm going to actually do it properly, because you can see my network ID is 5900. The thing is though, is that if I restart it, it may change. So that's why it may not be a good idea to match it exactly. No. And if it doesn't behave, it doesn't behave. If I wasn't doing this, I would actually have to build it separately, which you would have been able to see on remits if I remember how to use remits. And that would have created something called an ABI. Gosh, what does ABI mean again? Let's see. Ethereum ABI. I remember that. Right. Ethereum contract API, which is the application binary interface. To us, it will look just like a JSON file, but this is actually what our web application will be interacting with. So our web application doesn't have to directly interact with Solidity, just like how when we write SQL, our code doesn't directly interact with SQL. It ends up interacting directly with the database and however SQL is interpreted by the database. Same thing here. That's why I'm trying to bring that analogy of Solidity is the blockchain, what SQL is the database, which is, I hope, is a useful analogy. So if I go back here now, that was something. Right, so you just saw that it just compiled my smart contracts. But in order for me to actually migrate it, then that's going to be a different matter. So, you know what? First thing I'm actually going to just try to do is that I'm actually going to focus on getting this smart contract kind of stable path. I think everything here should be fine. One of the things that we're also going to want to do, though, is that just for this, like generally when you're building a smart contract, you're going to need not only the actual contract itself, that's why you define the smart contract, but also you're going to need to have the defining constructor. And the art of it is kind of important. Now, what I'm going to want to do is that I'm actually going to want to say, okay, you know what? I want to add a candidate. There's something here that's giving me errors. I'm not sure what. Oh, geez, my indentation. Oh, so one thing that probably everybody's laughing about is that I should be adding some kind of parameter here. Now, when you write your parameters for Solidity, you typically, I'm not sure if it's necessary, but you typically start them with underscore. And what's interesting, and that is exactly what VS Code was suggesting to me just now. If I could just show this again. Yeah. So if you notice it has unused function parameter, oh well, it's actually warning me about it. Let's see. And then I'm referring to string here. I think it should be just fine. Okay. So now that we have that, what we're going to want to do is that we're going to want to actually start building out our app. And we could do so in a very simple way. First, what we're going to want is to change. What we actually first just do is just get started with a source folder. Oops. Source. And then inside here, we'll add an index HTML. For our index HTML, I'll just quickly get started on some code. And I will also copy from Bootstrap, because who doesn't like Bootstrap? The JS is the CSS. Copy over to JavaScript. I actually don't need all of this. I don't need this. I will keep jQuery. There are two other things that I'm going to need. One, I'm going to create a new file here. I'm going to call it app.js. And I'm going to include that. And I'm also going to need Web3.js and Truffle contract.js. Now, Web3.js is actually what we use in order to interact with, for apps to connect to the blockchain. And this is usually via useful extensions like MetaMask. MetaMask being this extension, and also what you see when I pull this up. So basically what this means is that when I open up this extension, the way how the website itself could detect whether or not I have anything on the blockchain is via Web3. So I have various accounts I can open up in MetaMask, and you can see that I own and have different transactions I've done depending on each account. Web3 is what allows the app to interact with this and detect it, including like, okay, what tokens I have, what cent tokens I have, etc. So anyways, so how do I get Web3? Probably something else I've been playing with. So first, I think here is where I can find Truffle contract. I should have just prepared all these files beforehand. A half hour in. Oh, time's running up.
Yeah, you have about half an hour again.
I think we should be fine.
Okay, cool.
What I'm going to do then is I'm probably going to cheat a little bit. I'm just going to pull over a couple files just so I can grab some stuff. And rather than me having to look for this. I think everybody would appreciate it. And these are just libraries, so not actually pulling in direct code. Not yet, at least. Although that if time really starts to renovate. And the structure of code property kits. Oops. Okay, cool. Now I'm going to do the same thing here. There's a few things I'm going to want to do. First thing first is I'm going to want to have the I want to initialize Web3. I just mark it out in steps, just so I can connect with the smart contract which is being compiled. And not sure if you guys noticed, I actually have this in the wrong folder. That's interesting. Build source should be here. All right. So when I actually ran that build file, the truffle compiler, this created the same JSON here. This is the binary interface I mentioned before. So connect to the smart contract. The golden smart contract. And then I want to display the list of candidates. So how do I do that? If I just go back to Web3 documentation, then you can get a good idea how to do that myself, actually. And that would be via the app.js I just mentioned. So if I scroll down here, I can actually see use of the Web3 object directly from global namespace. I have to set a HTTP provider. And in this case, I'll be using localhost. And you can see the port number here. Just to remember, we're using 7545 and not 8545, which is what you saw before. Just to be safe, I'm going to close that Ganache build and I want to start over again. I can recompile my smart contracts, which really isn't necessary because it didn't actually change anything. And there's something here that's wrong. Okay, let's see what's wrong here. What's all this wrong? I'll use, what is that I'll use? That's not I'll use. I just used it. Oh yes, it's unused because I didn't use it on here. Yeah. I was just gonna add temporary information, but since commits didn't work anyways, that should be fine. So just know the compilation failed because it said error backward, which as every day. And now, as you probably will have seen when I was quickly going through the Truffle to actually write, I can now deploy, I can migrate to this network, basically deploying it to my local network. Now, conversely, I could also deploy this to the main Ethereum network, but that would be wise. The reason why is because then I'll actually need to use real Ether. I would need to use Ether, which right now costs, what is it? One ETH right now costs about 400 US or thereabouts. If I write Truffle Migrate, what this should do is that this would actually make use of the Truffle.js, the config that I have here, in order to figure out, okay, by default, it would try to deploy to the first one, well, typically to development, and it's going to use these parameters to do so. If I wanted to actually deploy to mainnet or to a testnet, which is kind of like a testing environment for blockchain apps, I would have to use something called Infura.io. Fortune is a free service, I think, still, but no. They are based to pay for it, but it's not necessary now. Okay, so if we take a look at this, let me clear this and this running one more time, just so you can see. I ran it with reset just to make sure that there are no issues and I try to interact with it off the blockchain. Blockchain being the local instance. And you can see my deploy migrations. Now what's interesting here is that you can actually see that I have addresses here for where I would have migrated and saved the artifacts. And also if I look back here now on the blockchain, you can see that I have some transactions here as well as an address. And you can probably see a similarity between these addresses, the transaction hashes, as well as what's seen here in console log. And my address as well being one that actually was logged in on MetaMask. That's why you're seeing here now 99.828 ETH. That's the same thing, well, kind of the same thing as what you're seeing out here on Ganache. If I run it on one of these other accounts, then these other accounts would have been depleted similarly. So this account 4 is actually the same thing here as the first account here. You can get that based off of the address. So that's all you do. Now, we then go back to here. Now we're going to get started in app.js. Let's speed it up a little bit. I already included it here. The first thing I'm going to do is I'm going to say app. Just define a few things. Contracts will be how many contracts I'm using. I'm not using any right now. And I'm going to initialize Web3. Now inside of here, we then go this code. And this code here is off of GitHub. This is their GitHub repository. I'll change it to 745. Okay. Yep. Yeah, and then I just return this. There's also something else I need to do. I also need to connect to the contract. So I'll say init contract. It's a JSON file that I'm going to read it. I have jQuery already, so I'm going to use get JSON. And you can see here voting.json. And we'll just call this product voting. Now, remember that we have contracts up here. So what I'm going to do now is I'm going to say app contracts voting is equal to, and here's where Truffle comes in. And after read the Truffle ABA, I'm going to use Truffle contract voting. Contracts voting. Provider. And this is saying, okay, well, hey, now we want to read using this provider. Like, obviously, I can't use Web3, so I'm going to need to do a little something here different. So I'm going to call this app.web3 provider. This is my global, basically. The way it is, I define a few globals. I'm going to say this return. So once I initialize, so this is me initializing Web3. I need to connect to smart contracts. There. This app is super connect contract. Oh, I'm looking at Shannon. I think this should be fine. So one other thing that we're going to want to get, we're also going to want to add like server. This would be so that we could actually run it on a server. So we could look at it on localhost. And then what I could also do is That's not too long. My package JSON, and I write like server here. Right. There, that's good there. Which means then if I write npm run dev, so I could not get what? That's interesting. That's oh, okay. Well, that's also called solver as well. This is really a requirement for running lake server. Okay, so that's it. Just not try. Oh. So this is deploying here, and then this is the right script. Okay, so it has some issues with our Web3 as well as the Truffle compile. Let's see if I can save to this. And this is because it's not in the right location. So let's just pull this over a little bit closer. Okay. So app.js now. So the app is kind of looking up. So app.js, and we have unexpected identifiers. So there's app.js 7, unexpected 97. Well, one thing to really consider is I actually haven't called the script. It's stupid of me. I mean, it would make sense to actually call the script, right? So what it should do is I should actually say, let's say, window load. Not sure why this is still unexpected. I think it's because it says, yep. That would be one of those bugs that if I hadn't written this before, it would be, oh, geez, why isn't this working? So another unidentified thing, and that's because of this as well. Okay, so get.json is now a function, which probably means that my jQuery isn't actually working. It's fine. Let's look for CDN for jQuery. Is that C? Yep. All right, cool. Well, the only thing that we're missing is, well, actual data on an actual app. All right. So we're kind of what I want to do now is actually just start defining, okay, well, hey, we're going to do, I would have liked to have a bit more time to be able to say, yeah, this is data here, but I would just say, okay, you're all candidates. And so what we're basically going to do is that we're going to fill in this candidates here. Option. It's really nice. Can we keep going?
Yeah, you can go ahead. Well, you have a few more minutes left.
Oh,
And so far, I haven't gotten any questions or comments as yet.
okay. On,
So,
do we have people on? Like, any questions
uh,
anyone?
no questions at all. People are viewing, but no one has any questions as yet.
Okay, that's not a problem. So what we're going to want to do then is that we're actually going to want to start getting some information from the user. So beneath this, what we're going to do is I'm going to put tag, I'm going to say case address, case address. So I will update that eventually. Okay, so yeah, so we see that here. And if I had it, so SAH2, this is candidates. Now, how to interact with contract. Now, one of the first things that you can do is that in order to find a user, the logged in user, or at least the user who deployed the contract, we can use this called web3.eth. This is a Web3 API, web3.eth.coinbase. And then we can also get some information from them, such as their balance, which would have been the same 99 that you saw when I was looking here. However, what we could also do, I was looking for it here, is a Web3 read contracts. I heard that. So look at Web3 here. So I'm actually using Web3 0.2 because 1.0 has bugs in it.
Okay.
Okay, sorry. So web.eth.contract. So if I have my API array, which should be the same JSON that you saw I mentioned here, then I could have grabbed it and used the ETH address, the ETH API, the Web3 API, sorry. However, instead of doing that, what I'm doing is that I'm using Truffle contract, which is here. So to instance of blockchain. Now, what I need to do is that I need to actually read from the contract. Now, what it says here is that I could actually deploy a new contract myself, or I can grab information from the deployed contract. And it's also other. Yes, no, this is the API and whatnot. Well, then instead is I'll just get started. So now that we have apps contracts loading, what I can do here now is actually something. Let's see. So I'm probably going to want to do app.render and start an attention. And that's already deployed. As you hear from the deployed contract. And floating instance. And floating instance. I'm looking back here. Did it keep? Then I can return this kind of something. I call it public because I want to make sure that I can actually access it in the actual contract. So
Okay, so I'm just giving you a quick time check. We have 5 more minutes.
well, you guys are very particular.
Yeah,
Isn't it?
yeah.
It was important. That's awesome. Okay, let's see if I can actually relate some actual functionality to this last minute. So what it would have gotten from this function here, voting instance.candidates count. Now what it would have gotten is that I would have actually gotten, because remember that every time I add a candidate, that would have added one candidate, then it would have actually gotten this number. So it's okay, so if I add one, then it should constantly be incrementing. So if I added a few other parties, these are Barbados political parties, not social parties.
Okay.
Then it should be 3. So I can do that instead. So I'm going to say, okay, candidates. Oh.
Okay, I'm seeing we have some questions. Okay, we have, does Ethereum library need to access a server somewhere?
So for my server, I'm actually using Ganache.
Okay.
So this actually is my server. However, if I want to run it and allow other people to connect to it, either they'll be trying to connect to my local blockchain, or I could put it up on testnet. And that was what I mentioned earlier. So there's some public testnets like Ropsten, Rankly, Povan, and that's typically how people would share and test their blockchain apps.
Okay, and then there's a next question. What's a .sol file?
.sol means solidity.
Okay. Well, I was asked if you could zoom in a bit on your editor, but seeing that we are like 2 minutes away to ending, I think the person would need to look at it in full screen.
Oh, geez.
To be able to view the code. And okay, so you have 1 minute. I'll give you a little extra minute overlay to wrap up.
So literally right now, if this is working,
Mm-hmm.
right now I should be able to actually know. Instead of me doing all that, I should just go say, okay, this will work. So if this is running, then it should run the render, and then it should just put okay, like let's go. Let's see what will happen. We'll change it, and then let me see it come up.
Okay.
I guess I'm out of time, but I'll keep going if anybody else wants me. I probably could start my own.
Yeah. So while you're doing that, I'll just inform if anybody needs to reach out to Shannon. His contact information is there in the description and the YouTube video to learn more about blockchain.
Yeah, so just as a closing then, what I should also say is that besides looking at what I've been doing here, since you guys will say you have a good introduction, you can actually go on Truffle's website and you can see a bunch of free setup examples, and literally you can run any of them very easily, just running npm install Truffle and then Truffle unbox.
Okay, great.
And then tell this.
Okay, so is there any other things that we'd need to see while? Okay, and I know I'm asking if that is there any other thing you would like to leave a closing comment?
Sorry that I couldn't get it all together, but it's like so lot there. But you did see Solidity, you did see a basic Solidity setup. And if anybody wants to continue, please send me a message.
Okay, great. Thank you again, Shannon, for presenting today. And guys, look out for us tomorrow. We will be having tomorrow morning microservice for sanity and saving with Lewis Kinley. So thank you all for joining us this evening. Have a wonderful evening and see you guys tomorrow. Bye.
All right. Bye.